हेलो गाइस। सो आज हम बिल्ड करने जा रहे हैं। मैं ही बिल्ड करूँगा। I'll be building GoTaskQ, a distributed job queue system in Go. So what it will do is, like, we will send HTTP requests and a pool of Go routines. Will asynchronously process them. Uh, you can think of like a bull MQ but made from scratch. I have already created the folder structure. You can see through this in GitHub. Now, today's work, I'll do firstly define some interfaces and then I'll just create a Snowflake ID generator which I'll build from scratch. So, stick through the process if you want to see how to build a Snowflake ID generator. Let me turn off my AI agent. I will build it from scratch without any AI help. So regarding this regarding the Snowflake ID generator, what we'll first need is epoch time, time from which we can reference. Let's take the current. No, I'm taking the epoch time for January 1st, 2026, which I'll copy from Google and just add it here. This will be a constant. That's normal. Okay. Next, we will define some constraints like what will happen. Just stick through it. I'll explain once I write. I'm thinking instead of adding constraints over the bit size, I'll just let the Go compiler handle it. So I'll remove int 8 and int 64 for now. So let me just give you the context what it means. So epoch is the time in milliseconds from the time it will serve as a reference for for our ID generation. uh, Here machine bits are the number of bits will store machine ID. Here timestamp bits are the number of bits we will store the current timestamp, and sequence bits are the number of bits in which we store the sequence. If same ID is generated at the same time, we can update the sequence. It can generate up. It will approximately generate 40. Sorry, I can just say like max sequence can be 4095. So it can generate IDs from 0 to 4095 that are approximately 40 that are exactly 4096 different sequences. So so per second we can generate, per millisecond we can generate 4096 unique IDs. And regarding machine bits, it will be like 1025, so 1023, and we will generate approximately 0 to 1023 machine IDs. So machine IDs will, so it can support up to 1024 machines, each generating 4096 IDs per second. That's for more reference I can give you, like, let me just check if I have reference for let me see if I have reference for the, no, I don't have the reference for Snowflake ID, but I can tell you that a Snowflake ID starts with a timestamp, then a machine ID, and then a sequence. Uh, the timestamps take the leftmost bytes, then the middle bytes are taken by the machine ID, and then the sequence is taken by the, and the rest bytes are taken by the sequence. In Let me just write max 22 bits for machine bits plus sequence bits. This means we can have only 22 bits maximum for sequence bits plus machine bits, because 41 bits will be taken by timestamps. And one bit will be for bit will always be set to 0 for making it positive. As in a 64-bit integer, if that bit is set to 1, it will be referred as a negative. Okay, let's go to the next thing. One second. Let's go. Next, we will define a struct. Let's define a struct. Oh, sorry. Let me just adjust. Okay. We will we will define a struct for the Snowflake. Let me just first create the struct. It will have a mutex so that at once only one goroutine can get the ID. It will help in tackling race conditions. Okay, then we will have a last timestamp. Let me name it last timestamp. That would be int 64. Then we will have machine ID. the machine ID on which we are generating the ID. 64. Then lastly we'll have a sequence. Current sequence. It starts from 0 up to 4095. Okay, that's all what we need for a basic struct. Let's just define some methods. Okay, firstly we will need to have a we'll need a Snowflake object. Let me just create a function, you will understand what I'm saying. Whenever you call new, we pass a machine ID, which is int64, and in turn we will get a struct Snowflake, a pointer to the Snowflake struct. Okay, here we will check if machine ID is negative or if machine ID is above the threshold we have set. We will just make that. For now, let's just panic. This is unrecoverable as machine ID can't be negative or can be greater than this. That's the constraint. For that we have just panicked. We can improve it later. For now, let's just stick to panic. If machine ID is not less than 0 or machine ID is not greater than, then we will just return the Snowflake pointer. With the machine ID set as machine ID we have passed. Okay, next, after that we can use the functions, for the struct. Next we can generate a function. We have to create a function for getting the current milliseconds before starting the Snowflake ID generation. Okay, so what it will take is nothing. It will just return a int64 timestamp. I mean current time in millisecond, reference to our epoch. It will return time in millisecond, current time in milliseconds. Okay, not relative to our epoch, it will just return the current time in millisecond. That we will check. The relative thing we will check in other function where we will generate the ID. Next function we will create is func. Let's create a function for waiting a millisecond. It will take last timestamp and wait for a millisecond. I'll tell you why we'll need it once I create it. Last milli that will be int 64. Okay, and it will generate int 64. So inside it we'll just take now time, which will be current millisecond, right? And we'll just run the for loop until now is greater than or equal to, now is less than or equal to last millisecond we have passed. It will update now to current millisecond, and then it will just return. Alright, I think everything is ready for our main generator function. Okay, I don't know where it is being used. Let me check. If I'm F. Okay, sorry, I was skeptical. Func. We will generate a function on the struct. Let's take a pointer to, then we will generate a function which will be next ID. It will just give out the next ID, which is int 64. Okay, so what we'll do now is start a mutex lock and defer the unlock. Okay, so whenever goroutine enters it, we will lock the access so that the race condition cannot happen and we can't generate more than one ID, more than one same ID. All IDs are unique. You will understand that, right? Okay. Next thing is we'll check now what's the time currently, which is current millisecond. Now this is a edge case. I can't say it is an edge case, it happens frequently. What if current time is less than last timestamp? So you'll think that's not possible and all, but it can be possible because of NTP network. On the network, sometimes clock adjusting can take some milliseconds away, so the time can decrease, like 5 or 10 milliseconds. It can be 5 or 10 milliseconds behind current time. So that's the edge case we have to handle. So let me handle the edge case. I'll tell you how we are going to handle it. Sorry for this. I'm accustomed to C and C++. Okay. If now is less than last timestamp, what it'll do? We can't panic. This is not a way to panic, not a good way to panic. If we panic, that can entirely disrupt our system. Since we know it will mostly be 5 to 10 milliseconds, and that doesn't create much disturbance, so we can just use if s dot timestamp s dot last time is minus now is less than 5. It means we can tolerate a error boundary around 5 milliseconds. I mean tolerate drift up to 5 ms. Okay, we'll do nothing, we will just have now equals to last timestamp. Okay, else now the case is what we'll do, else we can wait for the clock, which is a good way instead of throwing a panic. Now equals to wait next millisecond s dot last time s dot last stamp. This will help us recover it safely. Okay. Now what we'll do next is write the main functions. We have handled the edge case. Now we'll handle some more things like what if two requests are made at the same time for generating ID. So we will check if now equals s dot last stamp. If that's the case, we'll increase the sequence as I had told earlier that we will increase the sequence. All right, let me increase the sequence. S dot sequence equals to s dot sequence plus 1 and max sequence. So this is a very neat line of code. What I'm doing is I'm increasing the sequence by 1 and checking if the max sequence will give 0. Let me just tell you what I'm doing. Like, let's say 4095 is represented something like 000111 and something like so on. Okay, just understand like that. And 4096 will be represented something like 0001. When I add these two, I'll get 0. So I can check if my ID is greater than 4095 in this simple line. If my ID is greater than 4095, I'll just throw an error like that. Throw an error, or I can let me just then I will reset the sequence. That would be much better. Instead of throwing error, I'll reset the sequence and wait. Let me just write sequence equals to 0. If it is equal to 0, it means I have to wait. Let me just wait. What was the wait next millisecond, and the last timestamp is s dot last stamp. Or I can just say no because it was already equal. Doesn't matter. Let's go through the else case. If it is not equal to s dot last stamp, we'll just make s dot sequence equals to 0 for each sequence starts because each sequence starts from 0 to 4095. That's all. Next is I'll just reset the last temp to now. Okay, before I forget, and generate the ID. So how I'll generate the ID is I'll use OR and Also, I'll use bit shifting. Let me just write now minus epoch. It will give us the time relative to our epoch, and I'll bit shift it to bit shifted by timestamp shift, which we have defined above here, which was sequence bits plus machine bits. That is about 22. We will bit shift by 22 bits. Okay. Then I'll take OR with. Let me just take OR with machine bits. Let me just take OR with. Let me think about this. S dot machine ID. Sorry. Machine ID, which will be left shifted by machine shift, and then we'll take OR with S dot sequence, which will not be shifted at all. Let me just refund the logic. Okay, so let me tell you how ID is generated, and we will return the ID. Okay, so what I did was, let's say I have a timestamp of 111 and a timestamp shift of 3. Then I have a machine ID with like, I'm telling it a small scale, it's for 64-bit, but I'm telling it like that. Let me just frame it. So how can I frame this out for you? 0 0 0. There will be a big 64-bit chunk. In that we'll shift the timestamp by 22 bits. So 22 plus 41 bits of the timestamp will be like 63, and 1 bit will be always be 0. Let me just tell you how the structure will be: 0, then 41 bits of timestamp time, and then there will be 10 bits of machine ID, and then 12 bits of sequence. So this is how a Snowflake ID is structured. These are not shifted at all. These are shifted by machine shift, which was 12 bits. I have defined it here. Okay. Then we'll have 41 bits of timestamp, which will be shifted by 10 plus 12, that's 22 bits. Now let me just check through the implementation once. If I don't find anything unusual, I'll just say that it's done. I think it's done. I don't think I have left anything. We'll just see. Let's generate ID. Okay. I can't use it here. Timestamp bits is unused, which is, let's just comment it out. Okay, I think everything will work fine. Let's go to main.go. Let's try to test it out. Package, we'll take package main Okay, and func main Snowflake ID. News. Let me just create a Snowflake ID. Import Snowflake. Oh, I didn't include this. No. Let me see what I have done wrong. I think I have written something in. It's capital letters. It's Snowflake. Package Snowflake is right here. Okay, func main. Let me see. Import. Sorry, it's import Snowflake. No, github.com slash Snowflake. Let me see if I have done something wrong with the no. Let me just ask my AI. I'm new to this Go ecosystem, so I'm somewhat confused. Sorry. Oh, yes, I remember. I never defined it. I never defined it in the Go mod package. Sorry. Sorry. I think this should work now. Let me just run Go mod tidy. Define the module as. Let me just import with require. Shouldn't let me just search Google. Give me a second. paste it. Import and unblock. Google is also saying I should do something like this. Let me ask ChatGPT. Snowflake. But I have it in package. Okay, I have to publish it to GitHub first. Can't I do without publishing it to GitHub first? Let me just see. What a pain in the ass. Let me just check what ChatGPT said. Okay, I was writing this wrong import URL. Sorry, that was my mistake. Now let's check the ID generator. For this, I can just simply write a for loop. Snowflake dot name. Let's give the machine ID as one for now. We will use machine IDs from environment variables, something like that. And in later stages, we will generate a machine ID generator. We will create a machine ID generator, but for now, we will just hardcode the machine ID. And let's loop through it. 0 I less than 20 plus plus Let's generate some IDs. Okay, let's see if it works or not. We'll just build it. CD to CMD to server. Okay, go build. I know there's run command, but I like building and then testing. Okay. Sorry. Main. What was my package name? GoTaskQ. Where is it generated? Okay, it's generated in main. Okay. Gotcha. As you can see, we have different IDs generated. And I don't think there's some main. Every time different IDs are generated, and let's try. So our ID generation is done. I think that's all we need for ID generation for different jobs and queues. Now we can use this ID generator everywhere. Okay. I know the new format is range based now. 5. Am I not wrong? Okay. Now it's working fine. Clean. And next we will just. Okay. Done with the ID generation. Sorry, I'd never told you why I'm generating Snowflake IDs instead of UA IDs. Because we will not have a DB round trip and it will be safe for a distributed system we are building. Okay, as we build ahead, you will understand why I chose Snowflake ID instead of a normal UUID or UUID version 7 and something like that. Now let's start with some interface definitions. That's the main thing we have to do today. We'll define a struct for our jobs. How all jobs will look. Let me just get a thing. Okay, where are jobs? We'll delete the git keep file. And we will just create some job struct. I should name it job.go. Nothing fancy. It will be package will be main package. Okay. Okay, let's now do some things. For a job, there will be multiple status. Like job can be pending, running, done, filled, or sometimes it can be dead job. So we have to figure it out how we'll store it. I'm thinking I'll use string to store those. So I'll just create a type for status, name of type string. Okay, let me define what are the states of the status. Status pending. The type of status to pending. Also, I'll do some. I need status running. Instead, I'm thinking let's write them in capital letters. We'll have running completed, or we can say done. Okay. Then we will have failed queues. Then we'll have dead jobs. Sorry, I was talking about jobs. Then why did I say queues? Sorry. Let me just format these. That's all we need. We'll have status pending, status running, status done, status failed, and status dead. It needs to be. Let me format, and it's done. Now I'll define a struct for the job. Okay, a job will have an ID, which will be string. A job will have type, which will also be string. What other things will job have? A payload of the job, which will be JSON dot raw message. Do the payload the job is arrived with, like different requests can come. So raw message will just store bytes and will then marshal based on what we need. Then we'll have status priority. Type of status priority is our int. Okay, then we will have delay. That will be int, or we can say time dot duration is much better. Okay, then how many max retries can a job have? That will be int retry count. The count of retries the job is already done. If there's error, we will need to store to. Okay, next we'll need created at, which will be time, and updated. We'll need updated at. And what can a job do? We can schedule jobs to run after some time, so that will be good. After run after, which will be time dot time. So it will run after some time. Alright, let me just format it. Let me also define JSON struct, or we can define them later. JSON, how this will look in JSON. Okay, JSON, it will look like type payload with the payload will be the payload the job returns. Priority. JSON delay. These will be beneficial when we add monitoring. Like we can monitor a job, how many max retries the job have, and how many retries the job has already done. Should I return C and D? No. JSON. Let me just write error. And we'll omit the error if it's empty. Then the usual JSON created. Updated add. JSON run after. Okay. I think that's enough for a JavaScript. If we need anything more later, we'll add that. Okay. Okay. Next thing we'll need is to define some interfaces. Okay, let's start with the interfaces and the job. Let's create a job store. As you can see, I already have like this store.go where we will store interfaces and their implementation and how job can be stored in memory or in our database, something like that. Let's just write some implementation, some interfaces. Okay. Package main, let's go for main right now. Next we will need type store is a type of interface. Okay. What methods can we give a job? We can save a job, we can retrieve a job, we can update its status, and we can delete a job. Normal CRUD. So I can just give some methods like save a job. Let's pass context and job will be pointer to the job structure we just created in the last file. Okay, done. What will go give us error? Okay, next our get function. It will also have a context and it will have a context and an ID. Based on that ID, it will retrieve the job and it will return a job pointer to job struct and an error. Next, we will define update status. We can only update the status of the job, nothing more. Okay, we will need these two. We can't update, it should be immutable. Only the status should be mutable. Status will be string. Okay, then it will just give us error like save. If any error occurs, then we will have a delete. To delete a job, it will take string and context. This is some easy. These are some of the easy things. It will generate an error if it's not able to. Okay, let's also define our interfaces for Q. Q. So I have already decided to define interfaces in Q.go. Let me just write something. I'm not much clarified about the package, so I'll read about the package naming after the stream and see where I go. Okay, let's define some interface. Type Q interface. Okay, a queue can enqueue and dequeue. We'll give it a context. Context dot context, and I'll give it a job. It has to enqueue job dot job. It is undefined. I think we need to name this package job. Okay, store.go should also be named job. Q should be named as Q. Okay, and we can now use job dot job. Yes. Okay, now understood how folder structure affects packages. So internal contain packages which we don't publish, like allow users to publish, like you can understand what I'm saying. Context. Then we'll just have it context. We'll just give it context and it will just give it as job, which is a pointer to job and an error if anything comes. What's the problem? Missing parameter type syntax. What the hell? It's not a parameter. What is this? I don't understand why Go is behaving like this. Missing parameter type syntax var error and value type. Then how can this be? Type of error. What the hell? Okay, let's just stick to this for now. So it's a var error of type of error and type error. Nice. Next we'll need to check the length of the queue. It will give us an int and name of queue, as we'll have multiple queues, which will be string. Okay, it's done. Okay, it's done. I think that's majorly what I wanted to do for today. How much time it has been already? It's already been 1 hour. Let me check how much time. It's already been 1 hour, 3 minutes. Now the next thing, do I need anything more today before continuing tomorrow? Let me just check my checklist. Define queue interface, job store interface. Should I define the handler interface? Let me check my first day checklist. Config, job struct, and Snowflake ID. I have forgot about config. Yes, I have to write about config. Yes, that's the main thing I need to do. Okay, we'll generate a config. We'll create a config file. Okay, where's our config folder? Here's our config folder. Config.go. Okay. Config struct. Oh, now we'll need a port, which will be a string. And a max retries, which will be int. This I'll get from the environment variables, so I'm defining it here so that I can just have a function to get to load all the configs. Okay, this is enough for now. Let's just end the stream for now. I think this much is enough. I'll continue tomorrow. Okay, bye.